This is truly a tantalizing image. Why is it so captivating? This is Proxima Centauri. Since its discovery over 100 years ago, this star has fascinated astronomers around the world. It lies so despairingly close, yet it would take generations to reach. It is not visible to the naked eye, yet it is the closest star to our solar system. At one point, it was the lowest luminosity star known to mankind, yet also the most active one. As if these paradoxes weren't alluring enough, scientists have recently discovered a seemingly Earth-like exoplanet orbiting it, sparking conversations about interstellar colonization with names like Mark Zuckerberg, Elon Musk, and Stephen Hawking. It's almost as if Proxima Centauri is knowingly toying with humanity and our unquenchable curiosity for what lies beyond. If you're anything like me, you also can't wait to soak up everything there is to know about this enigmatic star. Hello, everyone. Today, I invite you to join me on a journey to explore the Alpha Centauri star system, home to the stars closest to Earth ever known to humankind. From the binary stars Alpha Centauri AB, we'll dive deep into everything we know about Proxima Centauri, its newly discovered planets, a controversial possible discovery, and even the exciting flyby missions the future might bring. Leaving Earth, it would take more than 4 light-years to reach the nearest stars to our solar system. I say stars because in reality, this is a triple star system. Collectively known as Alpha Centauri, it consists of Rigil Kentaurus, also known as Alpha Centauri A, Ptolemy, Alpha Centauri B, and Proxima Centauri. Rigil Kentaurus and Ptolemy together form the Alpha Centauri AB binary star system. They sit 4.37 light-years away from Earth, both sun-like stars orbiting a common center every 79.76 years. If you're south of the 40th parallel, you'd be able to see them at night, though to the naked eye, they just appear as a single star, the third brightest in the sky, behind only Sirius and Canopus. The binary Alpha Centauri system was discovered in 1689, but it would take over 200 years for the third star to reveal itself. Luck came in 1915 to a Scottish astronomer named Robert Innes. At the time, Innes was the director of the Union Observatory in Johannesburg, South Africa. While comparing astronomical photographic plates using a blink comparator, he noticed that a faint star had moved over the 5 years between 2 photos. This movement was about the same as that of the Alpha Centauri binary star he was observing. Innes began to wonder if this new star could be part of the same system. After further investigation, he concluded that it was even closer to the Sun than its twin siblings, a finding that was quickly confirmed by his contemporaries. Paradoxically, Proxima Centauri became both the closest and dimmest known star at the time. But the surprises didn't end there. In 1951, American astronomer Harlow Shapley discovered that Proxima Centauri is a flare star. Not only that, but it was the most active flare star known back then. Over the past 70 years, Proxima Centauri has become a hotly studied star, no pun intended. And with the recent discoveries of an Earth-like exoplanet orbiting it, I believe that interest will only intensify. But let's not get ahead of ourselves. Let's take a closer look at this star before placing such grand expectations on it. At 4.24 light-years away, Proxima Centauri is slightly closer to us than Alpha Centauri AB. It is a main-sequence red dwarf star with an estimated mass of just 12.2% and a diameter of 15% that of our Sun. Despite its smaller size, Proxima Centauri is about 40 times more dense than our Sun. Due to its low mass, the interior of Proxima Centauri is totally convective. This creates a magnetic field around the star and leads to the sporadic release of magnetic energy in the form of flares. As a result, Proxima Centauri randomly experiences drastic changes in brightness and energy emission. On May 6, 2019, a flare event on Proxima Centauri was observed as briefly being the brightest one ever recorded. These flares release radiation across the electromagnetic spectrum, including X-rays. To give you an idea of Proxima Centauri's solar activity, its baseline X-ray luminosity is roughly equivalent to that of our Sun, a much larger and hotter star. This level can increase by up to 2 orders of magnitude during a flare. If you enjoyed this video, don't forget to like and subscribe for more amazing content. Not only does Proxima Centauri have more intense solar activity than our Sun, it also has a higher frequency of it. It's estimated that 88% of the star's surface is active at any given time, much higher than our Sun, even at the peak of its solar cycle. But before you start picturing Proxima Centauri as a fiery ball of fury, remember, we are comparing apples and oranges here. Our Sun is not a red dwarf. In fact, compared to other red dwarfs, Proxima Centauri is considered to have a low activity level. Unlike the Sun, which scientists estimate will only burn through about 10% of its hydrogen supply before burning out, Proxima Centauri is predicted to use up almost all its fuel before leaving the main sequence in about 4 trillion years. And by then, Earth, our Sun, and our whole solar system will all be long gone. Alpha Centauri. AB is 0.13 light-years, or about 2 trillion kilometers, away from Proxima Centauri. You might be wondering, if Proxima Centauri is so far away from its companion stars, why is it considered part of the same stellar system? Well, we have data that shows it is gravitationally bound to the Alpha Centauri AB binary star, making it part of the stellar system with an orbital period of about 550,000 years. How Proxima Centauri ended up in this orbital situation is still open to speculation. But the 2 main scenarios seem to be either 1. Proxima Centauri was bound to the Alpha Centauri system during its formation, meaning the stars likely share the same elemental composition. Or 2. Proxima Centauri was captured by the binary star's gravity during an encounter, leading to a highly eccentric orbit that was later stabilized by the galactic tide and further stellar encounters. Regardless of how Proxima Centauri got into this triplet, calculations suggest that in 3.5 billion years it will get out. As Alpha Centauri AB continues to evolve and lose mass over its lifetime, Proxima Centauri will unbind from the system. The binary star system itself is also predicted to disassociate and diverge in about 12 billion years, turning into 2 white dwarfs, which will each forge independent and steadily diverging paths. Being our closest neighbors, we know quite a lot about Alpha Centauri AB. But we'll go into more detail about this binary star system in another video. For now, it's all eyes on Proxima Centauri. The search for exoplanets around Proxima Centauri had been ongoing since the mid-2000s, without much luck. But researchers weren't willing to give up. Not only was this star our closest neighbor, but it was also a red dwarf, 20 to 40% of which are thought to have a planet orbiting in a habitable zone. The patience paid off. Observations at the European Southern Observatory in Chile identified anomalies in Proxima Centauri that couldn't be explained by flares or other solar activity. The data seem to indicate there may be a planet orbiting Proxima Centauri. In January 2016, the Pale Red Dot campaign, a coordinated effort by multidisciplinary scientists and ground-based telescopes around the world, was launched to determine whether this suspected planet could be confirmed. In August of the same year, the discovery of the exoplanet Proxima Centauri b was announced. This planet has at least 1.07 times the mass of Earth and sits 20 times closer to Proxima Centauri than we are to our Sun. This exoplanet completes one orbit around its star in just 11.2 Earth days. Even though Proxima b is within Proxima Centauri's habitable zone, that doesn't mean it could sustain life. there are many other factors that determine habitability besides the presence of liquid water. For one, the intense solar activity would bombard the planet with 10 to 60 times the amount of UV and X-ray radiation we receive here on Earth. We'd probably need to invent SPF 3000 sunscreen to make the trip worthwhile. Another factor to consider is whether an atmosphere could even survive under such conditions. As far as we know, atmospheres are vital for maintaining surface pressure friendly to liquid water, for protecting against hazardous space weather, and for regulating a planet's climate. The radiation that Proxima b is exposed to could be enough to strip away the key components of an atmosphere over time. Frustratingly, we don't know much about Proxima b beyond its distance from its star and its orbital period. It's unlikely to have any moons, since their orbits would be unstable over long timescales. But the planet itself is thought to be tidally locked to its star. It also likely developed under extremely different conditions from Earth. Assuming it formed at its current distance from its star, it would have undergone a much faster evolution, experienced stronger impacts, and had less water. However, there is still some debate about its formation. Some scientists believe the amount of material in the protoplanetary disk would have been insufficient for such a planet to form at its present distance from the star. They say it's more likely that the planet formed farther out and gradually migrated inward to its current orbit around Proxima Centauri. Let me know what you think about Proxima Centauri in the comments. I'll reply to everyone. What the surface of the planet might look like is pure speculation. Theories range from an ice-covered planet to planet-wide oceans like Earth, though that's unlikely if the planet is indeed tidally locked, to a water-free world of only dry land, or perhaps a subsurface ocean like Europa. In short, no one knows. We haven't directly imaged the planet yet, so we'll have to wait for the first flyby to get a better idea. Something some moguls are already planning. If it happens, I have a feeling it will be just as earth-shattering as the Voyager flybys in the 70s and 80s, but more on that later. 6 years after the discovery of Proxima b, news of Proxima d swept global headlines. The first signs of the planet emerged in 2020, when a weak 5.15-day signal was detected in the radial velocity data during a study on Proxima b's mass. After further data collection and analysis, scientists announced the discovery of Proxima d in February 2022. So far, we know it is a sub-Earth planet, with at least 25% the mass of Earth, orbiting the star every 5.1 days. Sitting at a distance of 4.3 million kilometers, it orbits too close to have a habitable equilibrium temperature, which would be driven up to 87 degrees Celsius. It's also probably tidally locked, and would be bombarded with so much radiation that chances of finding life there are very slim. But this planet holds promise in another realm. It is the lightest planet ever to be detected with the radial velocity method. Since the planet is too far away to be seen with telescopes, scientists rely on a characteristic wobble anomaly in the movement of the star, which indicates the potential presence of a planet. The more massive the planet, the more obvious the wobble. In the case of Proxima d, the wobble was practically imperceptible. To me, the fact that we caught this faint wobble and were able to demonstrate with enough certainty that it is caused by a planet is a technological milestone worth celebrating. If only the world of astronomy were so cut and dry. Where there is breakthrough and celebration on one end, there is bleak uncertainty on the other. That's exactly where you'll find the controversial exoplanet Proxima c. Initially detected in 2019 using the same radial velocity method that found Proxima d, the existence of Proxima c was then confirmed in 2020 using Hubble astrometry data. However, in 2022, another team challenged the initial radial velocity data that led to the alleged discovery. They claimed the anomalies could instead have been associated with small, unaccounted systematic errors in the data extraction method the researchers used. Basically, a miscalibration. The trouble arises from the fact that, unlike Proxima d, which orbits incredibly close to its star, the data for alleged exoplanet Proxima c places it very far away from its star, with an estimated 1,928-day orbit. There is no similar example of a wobble detection of a planet with such a low amplitude at such a long period. That doesn't necessarily mean it's wrong, but it is going to require some confirmation from additional observations, says Paul Robertson, astronomer at University of California, Irvine. If Proxima c does exist, it will take a bit more data to convince reluctant skeptics. If it does not exist, it remains unclear why the Hubble astrometric data was able to corroborate and confirm a planetary signature. I guess we'll just have to wait and see what future studies find. With the recent discovery of Proxima b and how relatively close Proxima Centauri is to us, it is a perfect candidate for a future flyby. However, reaching our neighboring star system will take thousands of years using conventional propulsion technologies. Newer techniques like solar sails or nuclear propulsion might make such a trip possible within a human lifetime. Such ideas spearheaded the development of Project Breakthrough Starshot, an initiative set up by investor and physicist Yuri Milner, the late Stephen Hawking, and Mark Zuckerberg, which aims to reach the Alpha Centauri system within the first half of the 21st century. The idea is to conduct a flyby mission by sending microprobes weighing just a few grams at 15 to 20% the speed of light, and they think they could do it as early as 2036. With this timeline, the probes would reach Alpha Centauri in 20 years, and we on Earth would receive the first data 4 years later. After the initial flyby, the probes would possibly venture to the exoplanets and collect data on their atmospheric compositions, much like the Voyager missions did on our outer solar system decades ago. The team is pinning their hopes on the yet-to-be-developed Star Chip, a microelectronic gram-scale wafer carrying cameras, photon thrusters, power supply, navigation and communication equipment, essentially constituting a fully functional space probe, based on Moore's law, which states that the speed and capability of computers can be expected to double every 2 years. Bold and ambitious, the plan is not without its challenges. The team proposes to power these microprobes with 100 gigawatts of Earth-based lasers. That's the equivalent of the output of 100 large nuclear power plants, concentrated on probes just centimeters wide. Plus, all components of these tiny probes must be built to withstand extreme acceleration, cold, vacuum, and collisions with space dust. With this in mind, perhaps the project would more aptly be named Project Breakthrough Longshot. But if the history of space exploration has taught us anything, it's that missions faced with tremendous hardships and slim chances can become humanity's greatest milestones. Proxima Centauri might just be the next name to be written in the history books. Who knows? Maybe one day we'll get to witness that historic moment ourselves. Thank you for joining me all the way to the end of today's journey. If you enjoyed the video, please leave a comment, hit like, and subscribe to the channel so you won't miss our next adventures. Goodbye and see you in the next videos.